let's look at these two linear functions, and we're going to compose them both ways, simplify it down, and state the domain. So L1 of x composed of L2 of x, that's the same thing as just plugging L2 of x into L1. That's going to be L1 is 3x minus 14, but now x is going to be L2 of x, so that's going to be negative 4.5x minus 1.2. Okay, simplifying this down, we're going to distribute the 3. It's going to give us, let's believe it's negative 9, negative 13.5x minus 3.6 minus 14. That's going to give us negative 13.5x minus 17.6. This is just, again, a linear function. The domain is going to be negative infinity to infinity. All right, L1 of L2 of 15. We're going to plug 15 into L2 of x, and then we can plug that into L1 of x, or we can just plug 15 into the composed function I just found. So you could plug 15 into L2 of x, that'll give you some number, and then take that number, plug it into here. That's the same thing as just plugging it into this function. Negative 220.1. We're going to plug L1 of x into L2. So L1 of x is, or I should say L2 of x is 4.5x. L1 is 3x minus 14. The rest of L2 is that. So we plug in L1 in for x and then simplify. So I'm going to distribute the negative 4.5. Doing that is going to give me negative 13.5x negative times negative is positive, so we're going to get positive 63 minus 1.2, and of course 13.5x plus 61.8. This is the linear function, so the domain is everything. And plugging in negative 2.1 into there, of course, you can plug negative 2.1 into L1 of x and then plug that into L2, or just plug into here negative 13.5 times negative 2.1 plus 61.8. Calculating that. We get 90.15. We just wanted to show you this on the graph real quick for these two functions. These are just linear functions. As you can see, there are lines on the graph, and we have 3x minus 14 is this one, and L2 is negative 4.5x minus 1.2. And then I plugged in 15 into L2 and then plugged in L1, and we got negative 220.1. That was what we got. And then plugging in negative 2.1, I got 90.15, which is also what we got. And interestingly enough, you can actually, and Desmos allows you to plug in the two functions into each other, compose them on the graph. And so for this one, this green line here is the composition of L2 of x into L1 of x. So we could have just plugged 15 into this one. Now 15 is way out here, so we have to go down a long ways, and we get to this spot right here, negative 220.1. And then plug it in the other way, plug it in negative 2.1 into this one. Negative 2.1 is like around here, so we have to just scroll up a ways. There we go. Now, in addition to doing this, what you can do is look back at the original functions, and then, so for this first one, we plugged 15 into L2 of x. So plug 15 into L2 of x. Well, 15, that's the blue one. 15 is down here somewhere. You can do it like this. Of course, find it like that. Or you can just plug 15 in there by doing x equal to 15 and finding where it intersects. It intersects right there at negative 68.7. Then we take the output of that function, output of L2 of x, L2 of 15, and plug that into L1 of x. L1 of x, we're going to plug negative 68.7 into L1 of x. So now we're going to say x equals negative 68.7. Once again, that was just that y value. Plug it into L2 of x. It's all the way over here. Sorry, plug it in L1 of x. L1 of x is the red. We plug it into the blue first. Now you plug it into the red, and we get negative 220.1, the exact same answer from that one. So doing the same process for the other way, I'm going to plug in negative 2.1 into L1 of x. So negative 2.1 into L1 of x. L1 is the red line, so I'm going to plug in negative 2.1 into L1 of x. That's going to give me negative 20.3. Take that output and plug it into L2 of x. Negative 20.3. And that gives us, again, plugging it into L2 of x, we need to go to the blue line. We get out as an answer 90.15, which is exactly what we solved for here. So you can do this graphically if you want. The graphically can be a little bit more challenging because you have to make sure you're plugging into the right function. Especially so if you're doing it like I am. What would probably be easier is to start with this one, plug in the first one. Then once you have that, the answer to that one being negative 20.3. Turning that off and plugging into the second one. That way you're more careful with how you're doing it, making sure you're not getting confused. But that's how you can do it graphically. We have a quadratic here and then a rational, but with the absolute value inside of it. Simplify and save the domain. So here we're going to do f of g of x. So plug g of x into f of x. That's going to give us 50 minus 2 times x, which is now x plus 1 over the absolute value of x squared. And simplifying this, I guess we can multiply this thing out and see if there's anything that can simplify. X plus 1 times x plus 1 is 2x, no, x squared plus 2x plus 1 over the absolute value of x times itself is the absolute value of x squared. Interestingly enough, really, we don't need the absolute value here. This one, it doesn't matter if it's negative or positive. This will always be positive here. So it doesn't actually mean quite anything here. I think any value of x that we chose will always be positive. So there's no real reason to have that. But we'll just leave it in there for a moment and see. Now we're going to do 50 minus 50 plus 2x squared minus 2x squared minus 4x minus 1. And just distribute the negative 2 on top. I just wanted to show this here. X squared and the absolute value of x, and then squaring that. We get the same function. The outputs are the same for the two of them. Now, that doesn't mean that you can necessarily get rid of the absolute value in case you're going to be doing other things with the function. It's important to note that there was an absolute value there. But as long as you have, your work written out for you, then you can always keep that in mind. So we could, for instance, remove the absolute value of x squared and change it to x squared and then go on from there, because any output from this thing is always going to be this exact same thing as x squared. So with that in mind, let's go ahead and try it. Let's go ahead and change the absolute value of x squared to just x squared. And now we can combine like terms, and that's going to be 48x squared minus 4x minus 2 over x squared. And once again, you got to be careful when you're doing this kind of stuff because it might have an issue in the long run. But what I want to do is I want to plug in 1 into both this function that's been simplified down without the absolute value and this function here, because if we couldn't simplify it down, then that means we can't simplify any further past this function here. So I'm going to plug 1 into both of these and see what we get out. 1 into the top, this would be anyway our answer. So we're going to plug, it's going to be minus the 1 squared is 1 times 2 is just 2. Negative 4 times 1 is just negative 4 minus 2 over the absolute value of 1 is 1 squared. It's just going to be 1. That's going to give us 50 minus 2 minus 4 minus 2 or 42. Now for this one, plugging in 1 squared is 1 times 48 is 48. 48 minus 4 minus 2 is going to be 44, 42 divided by 1 squared is also 42. So we get 42 both ways, but in any regard, it's f of g of 1 is 42. Now plugging it into the other way, we're going to get g of x is going to be x, which is now f of x, plus 1 over the absolute value of f of x. Okay, on top, we can, of course, just drop the parentheses. On bottom, I can actually take out a 25. No, take out 2, I mean. And I get 25. 25 minus x squared. Absolute values around that. Combine like terms on top, we're going to get 51 minus x squared over, and then we have, this can actually be simplified down to 2 on the outside, absolute value of 5 minus x, 5 plus x. And this one, I believe we're going to need to leave the absolute value in because we can get negatives from this, right? If x is some big positive number like 100, we're going to get negative times a positive is a negative, and the absolute value does change the answer from that. So we can't actually simplify any further down from there. Plugging 1 into there, we're going to get 51 times 2 times 1 squared. So it's going to be 51 minus 2. So 49. 2 times the absolute value of 5 minus 1 is 4. 5 plus 1 is 6. 4 times 6 is 24. Absolute value of 24 is 24. So we're going to get 49 over 48. Okay, give it a try in number 1.